Right, welcome to question 2 of the Year 9 Acids, Reactions of Acids test. White vinegar can be made by distillation of brown malt vinegar. Here's the brown malt vinegar. We're going to heat it in a round bottom flask. We're going to heat it so that the water, which boils at 100 degrees C, and the ethanoic acid, which boils at 118 degrees C, we're going to heat it so that those two substances evaporate, turn into a gas. The gas passes around the tube, the gas cools down, and when gases cools down they condense, and so that the water and the ethanoic acid condense to form white vinegar here. The question says, why does the brown colour remain in the flask during the distillation? Well, we know that the water and the ethanoic acid are leaving the flask because they've evaporated. And we know that the boiling point of water is 100 degrees C and the boiling point of ethanoic acid is 118 degrees C. So whatever the brown stuff is, which is staying behind in the flask, it's not evaporating, it's not going up round there and condensing, so its boiling point must be more than 118 degrees C. Question B. Hydrochloric acid and ethanoic acid were reacted with magnesium to produce hydrogen gas. At the start, both acids were the same concentration, both pieces of magnesium were the same size. Give two observations which show that ethanoic acid is a weaker acid than hydrochloric acid. So let's think about this question before we answer it. Observations. We're being asked to give two observations. Observations are things that you can see with your eyes. Okay? Things you can observe. So we're going to write about things that we can see. And the experiment gives us, the question gives us a picture, right? So it's the picture we need to be looking at. Next part of the question, give two observations which show that ethanoic acid is a weaker acid than hydrochloric acid. So if it's a weaker acid, we're looking for things that show that it's got less of a reaction than hydrochloric acid, because it's weaker acid, less of a reaction. So looking at our picture, which two things that we can see show that ethanoic acid is a weaker acid producing less of a reaction? Well, look, for hydrochloric acid we've got all these bubbles of hydrogen. For ethanoic acid we've only got a few bubbles of hydrogen. So because there are fewer bubbles of hydrogen with the ethanoic acid, it must be a slower reaction, a weaker reaction, it must be a weaker acid. Now, what's something else that we can see? We're told that both pieces of magnesium were the same size at the start. Are they still the same size? No, this piece of magnesium in hydrochloric acid is much smaller than this piece of magnesium in the ethanoic acid. So this piece of magnesium must have reacted more quickly than this piece of magnesium. So ethanoic acid must be weaker because there's more magnesium left in the acid. C is a question about titrations. Okay, a student did a titration to find out if the white vinegar contains 5 grams of ethanoic acid in 100 cm cubed. Now this question is slightly confusing because we've always told you that the acid goes in the burette, and they've put the sodium hydroxide in the burette and the acid, which is the vinegar, in the conical flask. Now you can do it that way round, but it's normal the way that we've taught you, which is acid in there and alkali in there. So you needed to look at the picture carefully to get the answer of this right. Choose the correct words from the box to complete the sentences. Use each word once or not at all. We've got burette, we've got conical flask, we've got pipette, and we've got thermometer. To do this titration, 25.0 cm cubed of the white vinegar is measured using well, the key thing here is it's a fixed volume, right? It's a fixed volume, it's a definite volume, an accurate definite volume. To measure an accurate definite volume, I'm going to use a pipette. You weren't allowed to use one because they fall on the floor and break, yeah, sorry about that. But you saw me demo it with the rubber thing that fills the thing up, you know, blah, blah, blah. We then put the 25 cm cubed of white wine vinegar is then run into there. Look, here it is, it's in there. What's one of those things called? It's a conical flask, isn't it? An indicator is added to the white vinegar. Sodium hydroxide is added to the white vinegar from, what's this thing called with the end, with the tap? It's called a burette, isn't it? 2. How does the student know when to stop adding the sodium hydroxide solution? And look, there's 2 marks to get here. Now you're not told what the indicator is. And every indicator, there's lots of different indicators. There's phenolphthalein, there's universal indicator, there's methyl orange, there's lots of them. Okay, but you're not told which one it is. So you can't talk about a particular colour because you don't know which indicator it is. But what you can say is the student knows when to stop adding the sodium hydroxide when the indicator, that's a mark, changes colour for another mark. It's at the exact moment the indicator changes colour that the end point is reached. Okay. The titration is repeated 3 more times. The results are shown in the table. Titration 1, 2, 3, 4. Volume of sodium hydroxide in cm cubed 23.5, 20.1, 19.9, 20.0. The student decided that the mean of these results was 20.0. Explain why. Use the figures from the table in your explanation. So you've got 2 marks to get here and you've got to use the figures from the table in your explanation. Well, we know that the mean is an average, and we know to make an average we add up the individuals and divide by the number that we've added up. Now if you add these 4 up, you get 20, 40, 60, you get 83.5, and if you divide by 4 you'll find that that does not equal 20.0. Right? So she's not done that. She's not added those 4 up and divided by 4. And she's not done that because she's looked at them and gone 20.0, 19.9, 20.1. They're all within 0.1 of one another. So they're what we call concordant. They're all within 0.1 of a cm cube. So they're all concordant. This one though, well that's 3.4 different to that, and 3.6 centimetres cubed different to that, and 3.5 centimetres cubed different to that. So this one is an anomalous result. So what she's done is she said I'm not going to use that, it's an anomaly, I'm going to cross that result out, and now I'm going to add 20.1 plus 19.9 plus 20.0. I'm going to add all those up and divide by 3. If I add all those up I find that it works out to be 60.0. 60.0 divided by 3 is 20.0. And that's the end of question 2.